Today's lesson is called change in variable. It's a special type of U-substitution method to integrate a function. So let's take a look at two different type of functions. So here we have two similar integration. So on the left side is what we call traditional U-substitution method, where U in this case is 2x squared plus 1. Therefore, your derivative of u will come out to be 4x dx. And we have x dx equal to 1/4 of du. So we have 1/4 of an integral u to the 4th times du, where you could use power rule to integrate this. On the right side is a little different, because if you set u equal to 2x squared plus 1, your du will be 4x dx. And same thing as the other one, 1/4 of du will equal to x dx. But what happens in this case is you have u to the 4th, you have 1/4 of du, but keep in mind you have x to the 3rd, which it could be broke down to x times x squared. That's how you substitute x dx in for 1/4 of du. But we have x squared left, where you cannot integrate. So these are the scenario where we're going to use change in variable to solve the integration. So let's look at the same example as example 1. We said that u was equal to 2x squared plus 1. Du was 4x dx. 1/4 of du was equal to x dx. Again, so what we have is u to the 4th times x squared times x dx. Notice the x dx will substitute it with 1/4 of du. Again, the issue is we have that x squared there. So we're going to try to look somewhere in this equation where you could solve for x squared and turn it into u. And that's from the original variable you set your u as. We said u was equal to 2x squared plus 1. So we could say that u minus 1 over 2 is equal to x squared. So changing the variable of u into an x, in this case would be x squared, will allow us to solve this integration. So we have 1/4 integral of u to the 4th times u minus 1 over 2 du. Now the entire integration is in a variable of u. So 1/8 integral of u to the 5th minus u to the 4th du. Now we could use a power rule to solve this out. We have 1/8 times u to the 6th over 6 minus u to the 5 over 5 plus c. Just don't forget to substitute your u back in. So we have 2x squared plus 1 to the 6th power over 48 minus 2x squared plus 1 to the 5th power over 40 plus c is your integral. Okay, let's look at one more example. So in this case we have integral of x times square root of 1 plus 2x dx. So your u will be the inner function, which happened to be 1 plus 2x. So your du is 2 dx. So we could say 1 dx is equal to half of du. So we have integral of u to 1/2 power times x times 1/2 of du. Once again, we have the x there. we can't integrate this because everything has to be in variable of u. So we're going to look back to where you set your us and solve for the x. So we could say u minus 1 is equal to 2x. So x has to equal to u minus 1 over 2. So if you substitute u minus 1 over 2 into the x, we have 1 half integral of u to 1 half power times u minus 1 over 2 du. We do have a constant 1 half, so I'm going to factor that out to be 1/4. So we have integral of u to the 3 over 2 power minus u to 1 half du. So we could use a power rule once again to solve this out. So it'll be 2 over 5 u to 5 over 2 power minus 2 over 3 u to 3 over 2 power plus c. Now substitute your u back in and distribute that 1/4 and you should have your answer. So you have 1 over 10, 1 plus 2x to the 5 over 2 power minus 1 over 6, 1 plus 2x to the 3 over 2 power plus c is your answer to this. So change a variable is an additional step when you cannot integrate it because you have the extra variable that's other than u. So go back and find out where you could substitute that variable in replacement of u so we could integrate the rest to solve the problem.